Okay, let's get one thing straight, rockets are cool. They make loud noises, shoot fire, and blast people into space at 25,000 kilometers per hour. But they're also incredibly expensive, horribly inefficient, and let's be honest, kind of outdated. So what if, instead of blasting our way into orbit, we just took the elevator? Yeah, a space elevator. An enormous, tethered structure stretching from Earth's surface all the way into space. No rockets, no explosions, just a smooth ride to the stars. Sounds insane, right? Like something straight out of sci-fi? Well, maybe not as crazy as you think. Scientists have actually been seriously considering this idea for over a century. And if we ever manage to build one, it could revolutionize space travel forever. But before you start pressing the up button on an intergalactic elevator panel, let's talk about how this thing would actually work. How do you build an elevator to space? First off, you can't just throw a rope into the sky and hope for the best. A space elevator isn't just tall. It's impossibly tall. It would need to stretch at least 36,000 kilometers above Earth. That's 3 times the diameter of our planet. To put that in perspective, imagine stacking over 4,500 Mount Everests on top of each other. That's how tall we're talking. Now, you might be wondering, how does this thing stay up? Wouldn't it just fall back to Earth? Great question. The answer? Centrifugal force. See, Earth is spinning really fast, about 1,600 kilometers per hour at the equator. If you extend a cable far enough into space and anchor it properly, the outward force from Earth's rotation will keep the whole structure stretched tight, like a yo-yo string swinging around in circles. At the very top of the elevator, you'd have a counterweight, something massive to balance everything out. This could be a big space station or even a captured asteroid. Yes, stealing an asteroid and using it as a giant weight in space is an actual engineering proposal. What's the elevator made of? Here's the real problem: materials. You can't just build a space elevator out of steel or concrete. Those would snap under their own weight long before reaching orbit. We need something stronger than anything we've ever built before. A material with insane tensile strength that can support a structure tens of thousands of kilometers long. And that's where things get tricky. Right now, the best candidate is carbon nanotubes. Microscopic cylinders of carbon atoms that are 100 times stronger than steel and lighter than plastic. The problem? We don't know how to mass-produce them at the scale we'd need. Scientists are working on it, but until we crack that problem, the space elevator remains more of a dream than a reality. Okay, but why bother? Why not just keep using rockets? Well, imagine booking a plane ticket and the airline tells you that 80% of the cost goes toward throwing the plane away after one flight. That's basically how space travel works today. Rockets are expensive because they require tons of fuel and are single-use, meaning we throw most of them away after every launch. A space elevator, on the other hand, could transport materials and people into orbit for a fraction of the cost. Instead of paying $10,000 per kilogram to send something into space, a space elevator could bring that cost down to just a few dollars. That means bigger space stations, more satellites, and maybe even permanent human colonies on the Moon and Mars. It would also make space accessible to way more people. Right now, astronauts spend months training just to survive a rocket launch. With an elevator, space travel could become as routine as taking a long-haul flight. But wait, wouldn't this thing be a giant target? Absolutely. A space elevator isn't just big, it's also vulnerable. Imagine if a satellite crashed into it, or worse, a terrorist attack. One well-placed explosion, and suddenly you have tens of thousands of kilometers of falling cable wrapping itself around Earth like some apocalyptic spaghetti. Not to mention, the elevator would have to survive hurricanes, lightning strikes, earthquakes, and even micrometeorite impacts. Engineers have proposed some clever solutions, like designing the cable to burn up in the atmosphere if it ever breaks. But it's still a massive challenge. Would it even work on Earth? Here's the kicker: building a space elevator on Earth is so difficult that it might be easier to build one somewhere else first. Like the Moon. The Moon has much lower gravity and no atmosphere, which means you don't have to worry about hurricanes or strong winds messing things up. Scientists think we could build a lunar space elevator with existing materials, and if it works, we could use it to transport supplies from the Moon's surface to lunar orbit, paving the way for permanent bases. Mars is another possibility. If we ever colonize Mars, A space elevator could make it much easier to send people and cargo up and down without using fuel-hungry rockets. So, will we ever build one? The idea of a space elevator isn't science fiction. It's based on real physics and engineering. But the biggest hurdle is materials. Until we create something stronger than anything we've ever built, the dream of riding an elevator to space remains just that, a dream. But here's the fun part. If we do figure it out, it could change everything. Cheaper space travel, more space stations, lunar and Martian colonies, maybe even a permanent human presence beyond Earth. So while it might sound crazy, don't be surprised if one day, instead of blasting off in a rocket, future astronauts just step into an elevator, press up, and ride their way to the stars. If you enjoyed this wild thought experiment, don't forget to like, subscribe, and hit that notification bell so you don't miss the next deep dive into absurd science. Thanks for watching, and I'll see you next time.